Hi guys, and welcome to the video on counting combinations. So, we're learning to count the number of available ways to arrange a set when the order does not matter, and we're learning this because counting groups is important in calculating the total outcomes for probability. And then you can use the formula to calculate the number of possible ways to select something when the order doesn't matter. That's how you know you are successful. So, combinations. A combination is a way of picking all or part of a set of objects without caring about the order in which they are chosen and without repetition. So previously we talked about having a set of 3 letters in the permutations video, A, B, and C. When we arranged them, we had 6 different permutations because the order was important. For a combination though, AB is considered the same as BA, so they are not unique. So take a look down here. When I had A, B, and C, my original letters were A, B, and C, and I took them 2 at a time. I was doing 3 NPR 2, and I took them 2 at a time, and I had listings like AB, AC, BA, BC, CA, and CB. Because of how combinations are structured, A, B, and BA are the same exact combination, even though they are different permutations. So AC and CA are the same combination, and BC and CB are the same combination, despite being different permutations. So there are only 3 unique combinations here. So remember that we again are not repeating our choices. So once something is selected, it cannot be chosen again. Also, combinations are generally more restrictive than permutations are, because in a scenario like the last slide, the 3 letters led us to have 6 permutations, but only 3 combinations. And we take that into account in our formula by using the following formula. The choices, or the combinations available for n objects taken r at a time is equal to n factorial divided by r factorial times n minus r factorial. And in just like the permutations, we have a calculator shortcut found in the same way. You go to the math menu, go over to the PRB, and it's option 3, NCR. So let's just dive straight into some examples. Mr. Lewandowski needs to pick 5 students to be on the student basketball team. How many different teams can he make if he has a pool of 50 kids to pick from? So you've got n equal to 50. You have 50 kids, and you are selecting 5 at a time for the team. So the formula would be, so the number of combinations for 50 5 would be equal to n factorial on the top, so 50 factorial divided by the next one's r factorial, and then remembering back, the other one is n minus r factorial, so 50 minus 5 factorial. And so when we calculate this out, remember our calculator has that shortcut where we could put in 50 NCR 5. That's equal to 2,118,760 different teams that can be made. Now, believe it or not, if we were to actually do this with permutations, the amount of teams would go up by a lot. So, first example, down. Another example. Mr. Wirtz has 12 students that need to be arranged into groups of 4. How many different groups can be formed? So, n equals 12 here. R equals 4 because we are selecting groups of 4. And so what we are then going to do is substitute that in. C of 12 comma 4. Again, I'm showing all of my work so that you understand the mathematics behind the combinatronics here instead of just as a calculator shortcut. So it would be 12 factorial over 4 factorial times 12 minus 4 factorial. Oh, I gotta close my parentheses, then the factorial. And then that is the equivalent of putting the 12 NCR 4 in. This would be 12 factorial over 4 factorial times 8 factorial. And then when all is said and done, there are 495 groups possible. That doesn't mean that there are going to be 495 groups. There's only going to be 3, but what's happening is I could make a combination with all the different kids. I could create 495 different groups with those groups of 3 or 4. All right. Sarah, Jack, Ella, and Ian, and Sam and Victoria are members of the Model UN Club. They need to select 3 members to form a committee that will be in charge of choosing the new members of the club. How many unique combinations are there for their committee? So, I see 1, 2, 3, 4, 5, 6 different members. So, N equals 6 because I have 6 different members. And R is equal to 3. So if I set up my formula for C 6 comma 3, I would get 6 factorial over 3 factorial times 6 minus 3 factorial, which simplifies to 6 factorial on the top over 3 factorial times 3 factorial on the bottom. And when I go ahead and use 6 NCR 3 as my calculator shortcut, we came up with 20. There are 20 ways, 20 combos that they can create for their committee in order to select new members. Okay, so here now I have an example that's going to directly compare and contrast combinations versus permutations. So, how many different ways can you combine 4 letters from the word triangle? So that word combine indicates combination. That we are going to use the formula for combination. In triangle, there are 8 letters. So there are 8 letters. And we are picking 4. So what I will do is say that N equals 8, R equals 4. So if I set up my combinatronic equation here, I do C of 8 comma 4 would equal 8 factorial on the top over 4 factorial times 8 minus 4 factorial, which would simplify to 8 factorial over 4 factorial times 4 factorial. And running that through the calculator, I would get that there are 80 combinations. So there's 80 different ways that I can combine the letter, 4 of the letters from triangle in some unique way. Now, if you look at this other example here, how many different ways can you arrange 4 letters from the word triangle? So the word arrange is a big big like flair for permutation. So here we're going to use the permutation formula. So this is a permutation, and again, n equals 8 here, and r equals 4. So I'm going to do p of 8, comma 4. And the permutations formula is very similar. Again, we're going to do n factorial on the top over n minus r factorial on the bottom. So 8 minus 4 factorial, which simplifies, I want to use an arrow, simplifies to 8 factorial over 4 factorial. And this leaves us with quite a few more. In fact, it leaves us with 1,680 arrangements. So there are 1,680 different arrangements of the 4 letters in the word triangle, but there are only 80 combinations. So it kind of shows you how restrictive a combination is because the order doesn't matter. So you cancel out a lot of the different arrangements that you would get from all the permutations. So there's a good compare and contrast of when to use combination versus permutation. So then finally, a nice real world example for you guys. Thomas is ordering a 2-topping pizza from his favorite pizza place. If there are 12 available options, how many unique combinations can he get on his pizza? So obviously, if you ordered a pizza and you ordered pepperoni sausage, it would be the exact same thing as getting sausage and pepperoni together. So we don't have a permutation here. Instead, we have a combination. We know that there are 12 unique options. And Thomas here is going to pick 2 of them. So we're going to do the combinatoric equation for combos here of 12 picking 2 at a time. And that gives us 12 factorial on the top over 2 factorial times 12 minus 2 factorial, which would be 12 factorial on the top. Oh, I'm going to fix my 12. That would be 12 factorial on the top over 2 factorial and times 10 factorial. And when all is said and done, it leaves us with 66 combinations. So Thomas has 66 different choices for combinations on his pizza. So, in summary, guys, combinations are ways of selecting from a larger set of people or things and then putting them in groups, and we don't repeat when we make those picks, and we don't care about the order in which we select them. We can calculate with the formula, and we're using the calculator shortcut in order to do so. Remember to format in the same way that you should have N, the number of options available to you, C in the middle, and then R, the number of picks that you are making at a time. So that's it for counting combinations, guys. Thanks for watching, and I'll see you in the next video.